It sometimes really hits you how these wild movie monsters,
Yeah.
they aren't always just pure fantasy.
Right.
Like, think about Jurassic World Dominion. They had that Atrociraptor. And it was portrayed as this, like, really brutish, heavy-duty version compared to the Velociraptors in the film.
Yeah, almost tank-like, wasn't it?
Exactly.
Yeah.
But the kicker is, it's not just movie magic. It's a real, actual dinosaur.
Hmm.
I saw this quote from a writer of film who joked you could even look it up on Wikipedia.
And that's actually perfect because that real dinosaur is exactly what we're diving into today. We're going deep on Atrociraptor marshalli. It was a dromaeosaur. It's stalked around in the Late Cretaceous in what's now Alberta, Canada.
Right. And our mission, if you will, is to understand this savage robber, which is quite the name translation, isn't it?
It definitely paints a picture.
It does. And we're going straight to the science. We'll look at, how it was found, how it got classified, what makes it unique,
Yeah.
its relatives, the world it lived in. And it all started with one person, right? A guy named Wayne Marshall.
Precisely. Wayne Marshall. Our goal today is really to unpack what makes Atrociraptor stand out, what its discovery tells us about that whole late Cretaceous dinosaur world, and also try to pin down its spot in the family tree, which, as we'll see, has been, well, a bit of a journey.
Okay, so let's get into that discovery. It was 1995. Wayne Marshall's near the Royal Tyrrell Museum, out in the Horseshoe Canyon Formation, finds something. And he wasn't just like a tourist, right? He knew the museum people.
Yeah, he had a real connection. He'd even worked in their mounting shop, apparently. So definitely someone who knew what he was looking at and knew to report it properly, which is key.
And what did he actually find eroding out?
It started with bits of jaws and teeth just weathering out of a hillside. So Marshall collected those initial pieces, took them to Dr. Philip Curry at the Tyrrell, and then later excavations turned up more bits from the same animal.
And these weren't just any old bones. This became the main reference specimen, the holotype.
Exactly, the holotype. Catalog number RTMP 95.166.1. And it's super important because it's the benchmark. Everything else found later gets compared back to this specific set of bones.
So what did it actually include, this holotype?
It comprises both premaxillae, those are the very front bones of the upper jaw. Then there's a right maxilla, the main upper jaw bone, both dentaries, the lower jaw bones that hold the teeth, plus a bunch of teeth that were associated with it, and some other skull fragments. And apparently a lot of it was stuck inside this really hard block of sandstone initially.
Wow. Okay, so fast forward a bit to 2004. It gets its official name from Curry and David Verricchio, Atrociraptor marshalli. Tell us about that name. Sounds fierce.
It really does.
Yeah.
Atrociraptor comes from Latin, atrox meaning savage or cruel, and raptor meaning robber or thief. So yeah, savage
robber.
And then marshalli, the species name, that's a direct honor to Wayne Marshall, the discoverer. So Marshall's savage robber.
A very cool name and a nice tribute. And the science didn't stop there, did it? I think I read something about CT scans more recently.
That's right, yeah. In 2022, Mark Powers and colleagues used CT scanning on the holotype, which is great because it's non-destructive, lets you see inside the bones, find details you couldn't see otherwise.
Ah, clever.
And also, since that first find, lots of isolated teeth from the Horseshoe Canyon Formation, some that people originally thought might be Saurnitholestes, they've now been assigned to Atrociraptor.
Oh, interesting.
Yeah, some even turned up in that famous Albertosaurus bone bed at Dry Island Buffalo Jump Provincial Park.
Wow. Okay, so the picture keeps getting clearer. Let's talk about what this thing actually looked like. It's a dromaeosaurid, so I assume it has the classic raptor features.
Absolutely. Based on what we have and comparisons with relatives, we estimate Atrociraptor was maybe 1.8 to 2 meters long. So roughly 6.5 feet, weighed about 15 kilos, maybe 33 pounds.
So similar size to Velociraptor then.
Yeah, pretty much in that ballpark. And definitely as a dromaeosaurid, it would have that big, curved sickle claw on the second toe. The iconic one.
Can't forget the claw.
Yeah.
And feathers, presumably.
Almost certainly. We have great evidence for feathers in related dromaeosaurids like Zenu and Long. So it's highly likely Atrociraptor had complex pennaceous feathers too. Maybe even wing-like structures on the arms, long tail feathers, the whole deal.
Right. Not just scaly movie monsters. But what made Atrociraptor different? You mentioned its naming savage robber. Was there something anatomically distinct about it compared to, say, Bambaraptor or Saurnitholestes?
Okay, yeah, this is where it gets really interesting. The big thing is its face. The snout was much deeper, much more robust than in those other guys.
Deeper? How so?
It's just like taller from top to bottom. And along with that, the teeth in the maxilla, the main upper jawbone, they angled backwards much more strongly. And maybe the most distinctive thing, the teeth were almost all the same size, kind of isodont-like.
Isodon, meaning...
Meaning similar-sized teeth along the jaw, unlike many other dromies where the teeth might vary quite a bit in size.
Huh. And that deep snout, those teeth.
Yeah.
Any ideas what that means? Bite force?
That's the thinking, yeah. A more robust skull probably means a stronger bite. Maybe it was going after tougher prey than its more lightly built cousins.
Interesting. Okay, let's dig into those skull details. You mentioned the premaxilla, the very front.
Yeah.
What was special there?
Right, the premaxilla. It had 4 teeth on each side, which is pretty standard. But the part of the bone below the nostril opening, it was taller than it was long, which is actually similar to Deinonychus and Utahraptor, but different from Velociraptor and Saurnitholestes.
Okay.
And because the whole snout was so deep, some of the bony processes, like the subnarial process below the nostril, pointed more upwards than backwards compared to other dromaeosaurids. Little details, but they add up.
And the teeth in that premaxilla?
Yeah.
Anything stand out?
Well, based on the sockets, the second tooth seems to have been the biggest. That's seen in some relatives, too. The teeth themselves were kind of J-shaped in cross-section, not D-shaped. And the serrations, the little cutting edges, pretty similar front and back, about 2.3 to 3 serrations per millimeter.
Gotcha. Okay, moving back to the maxilla, the main upper jawbone. You said it was deeper. Can you elaborate on that?
Yeah, the whole bone was roughly triangular, but definitely deep. The distance between an opening called the maxillary fenestra and the tooth row was more than twice the height of the biggest tooth. In other dromies, it's usually less than twice.
So definitely a tall snout.
Exactly. It confirms it wasn't just short, it was genuinely deep. The big opening in front of the eye, the antorbital fenestra, was relatively small, though. But another opening, the maxillary fenestra, was actually larger than in relatives. And the whole lower edge of the maxilla had this strong convex curve.
And it held 11 teeth, you said. What about them, besides angling back?
11 teeth, yeah. Tightly packed. And interestingly, the holotype specimen, no empty sockets. Which is a bit unusual. You often see gaps where teeth have fallen out.
Yeah.
These teeth were blade-like, narrow side to side. And that strong backward slant is really only matched by Bambaraptor and Deinonychus. And again, that near isodon condition, very similar sizes all along the row. Not like Velociraptor with its alternating big and small teeth.
And any difference in the serrations on these maxillary teeth?
Yeah, the back edge had larger serrations, about 3 to 4.5 per millimeter. The front edge had smaller, more numerous ones, maybe 5 to 8 per millimeter. And the back ones had these little hooked tips.
Okay, finally the lower jaw, the dentary. How did that compare?
Generally pretty similar to other dromaeosaurids. Upper and lower edges mostly parallel. It had the usual rows of little foramina for nerves and blood vessels. Thin, side to side, nothing too out of the ordinary there structure-wise.
How many teeth in the lower jaw?
Well, the fossils are incomplete, so it's an estimate, but are probably around 12 or 13 total. The right side preserved 10 sockets, the left had 6. The teeth themselves seem smaller than the upper teeth and not quite as strongly angled back. Still blade-like, narrow, with more serrations on the front edge than the back.
So a really unique combination of features, especially that skull and the teeth, which I guess leads us straight into the big question. Where does Atrociraptor actually fit in the Dromaeosaur family tree? What's its classification?
Okay, so it definitely belongs to the family Dromaeosauridae, no question there. And within that, it's part of a large group called Eudromaeosauria, the true dromaeosaurids.
Right.
This group, Eudromaeosauria, includes several subfamilies like the Velociraptorinae, the Dromaeosaurinae, and the Saurnitholestinae. Now, there's actually some debate about where Eudromaeosaurs first evolved in North America or Asia and how they spread out. And where the Saurnitholestinae fit into that picture is kind of a key point in the argument.
And Atrociraptor's position, is it clear where it slots in? Sounds like maybe not, given the incomplete fossils.
Yeah, exactly. That's the tricky part, because the holotype is just, this few skull bones and teeth. Pinning down its exact relationships has been tough. It shares some features with Dromaeosaurus, some with Saurnitholus, even some Asian forms like Shri or Kuru.
So it's a bit of a mix?
Kind of.
Yeah.
And because it's ambiguous, some phylogenetic analyses those studies that reconstruct evolutionary trees have actually just left Atrociraptor out altogether sometimes, just to get a clearer picture of the other relationships. It really shows how science works with limited data, Our understanding evolves. Its position has definitely bounced around a bit.
Yeah, I can see how a piece that doesn't quite fit cleanly could muddy the waters.
Yeah.
So what were some of those earlier ideas about its relatives? Where did they place it initially?
Well, when it was first named back in 2004, Curry and Verrocchio thought it looked pretty close to Deinonychus and put it in the Velociraptorina. That was based mainly on tooth serration patterns and the size of that second premaxillary tooth. But they did say even then that this might change.
Okay, so initially maybe a velociraptorine?
Then, in 2009, a study by Longrich and Curry suggested something different. They grouped Atrociraptor with Sauronitholestes into a new subfamily they proposed, called Sauronitholestinae.
Ah, okay. So a shift towards Sauronitholestes fairly early on. What came next? Did things get clearer?
And not immediately. By 2012, another group, Turner and colleagues, pointed out that the few studies that had included Atrociraptor were getting conflicting results. There just wasn't a consensus. Then in 2013, Evans and his team, when they described Acaraptor, suggested Atrociraptor might be the closest relative, the sister taxon, to Deinonychus. But crucially, they placed this pairing outside of Velociraptorinae and Dromaeosaurinae, though maybe slightly closer to them than Sauronitholestinae was.
Wow. Okay. So sister to Deinonychus, but in its own little group. Any other ideas?
Briefly, yeah. Around 2015, some analyses hinted it might actually belong inside the Dromaeosaurinae subfamily, along with Deinonychus. But that didn't seem to stick for long.
So where does the thinking generally sit now? Is there more of a consensus?
It seems so, yes. Most of the recent, really comprehensive analyses, like those using the big twig dataset and other updated information, they consistently find Atrociraptor nesting within that Sauronitholestinae subfamily.
So back with Sauronitholestes and its kin seems to be the current favored spot.
Pretty much, yeah. It's a great example of the scientific process, refining ideas as more data comes in.
Definitely. Okay, so let's shift gears a bit. Those unique features we talked about, the deep snout, the teeth, they must have implications for how it lived, right? What it ate. What's the thinking on its paleobiology?
For sure. Gregory S. Paul, back in 2016, suggested that robust skull and teeth might mean Atrociraptor was adapted for tackling bigger prey, maybe inflicting more damage than some lighter-built relatives.
Makes sense.
And Mark Powers and his team expanded on that in 2022. They noted that dromaeosaurs with these deeper maxillae, like Atrociraptor and also Deinonychus, are generally seen as active predators, maybe specializing in larger prey. Their size and those fewer, larger serrated teeth point that way. They contrasted that with velociraptorines, which often had longer, narrower snouts, maybe better for smaller, quicker prey. And then smaller guys like Acaraptor or Sauronitholestes might have been more generalist feeders.
Right. So the skull shape maybe hints at its niche. And we have to talk about the claw, that big sickle claw. What's the latest thinking on how Atrociraptor and other dromies used it?
Ah, yes, the claw. It's been debated for ages. Slashing weapon, climbing aid, all sorts of ideas. But a really influential model came out in 2011 from Denver Fowler and colleagues, the Raptor Prey Restraint Model, or RPR.
RPR. What's the idea there?
The basic idea is that they use the claws primarily to grip and pin down struggling prey, like talons on a bird of prey. While the prey was pinned by the feet, they could use their jaws to, dispatch it. Fowler's group also suggested maybe there was a shift from using hands to using feet for restraining prey, especially as the arms got more feathery. Maybe the arms were used for, stability flapping during the struggle, like modern hawks flapping to stay balanced on top of prey.
That's a cool image. Feathered arms flapping for balance. Has that RPR model held up? Any newer research?
Yeah, it's pretty well supported. There was a biomechanical study in 2019 by Peter Bishop. He did detailed 3D modeling of the hind limb of Deinonychus, and his results backed up the idea that the claws were really well suited for grasping and holding prey smaller than themselves.
Okay.
But interestingly, he didn't completely rule out other uses, like maybe stabbing or cutting at close quarters, perhaps from a crouched position. So the main function seems to be RPR, but it might have been a bit more versatile, a multi-tool perhaps.
Okay, potentially more than one trick up its sleeve or
Yeah.
on its toe. Now let's step back into its world. Late Cretaceous Alberta. What was the environment actually like? The paleoecology?
Right, so the holotype specimen itself comes from the horse thief member of the Horseshoe Canyon Formation. That's the second oldest part of that formation, dating to the Maastrichtian age specifically, about 72.2 to 71.5 million years ago.
Okay.
But remember, those isolated teeth found elsewhere. Some come from the younger Tolman member, which is maybe 70.9 to 69.6 million years old. So that suggests Atrociraptor might have actually been around for over 2 million years, maybe longer.
Wow, quite a run. What was the climate like back then? And the landscape.
Well, this part of Laramidia, ancient North America, was further north than it is today, maybe about 8 degrees more latitude. But despite that, it was much warmer. Average annual temperature around 10 degrees Celsius, that's about 50 Fahrenheit, compared to maybe 4.5 C or 40 F in Drumheller today.
Much warmer. And the environment itself.
The horse thief member, where the holotype is from, looks like it was a coastal plain or maybe a big river system right on the edge of the western interior seaway. Lots of evidence for humid wetlands. Coal seams, shales, mudstones full of organic stuff, points to a high water table. And finding lots of diverse turtle fossils in those lower layers really backs up that wet, humid picture.
The swampy, maybe? Did it stay like that the whole time Atrociraptor was around?
Not entirely. As time went on into the later Maastrichtian, that big western interior seaway started to shrink. And that probably led to somewhat drier conditions further inland. We see hints of that in the sediments of the younger Morin and Tolman members.
Okay.
But even then, there were still major floods sometimes, like the event that created that Albertosaurus bone bed, which, remember, also had Atrociraptor teeth in it. Interestingly, right near the very end of the Horseshoe Canyon Formation, around 68 million years ago, things seemed to get wetter again, more like the earlier horse thief conditions.
But no Atrociraptor found that late.
Not so far, no. No remains from those uppermost, wettest beds. Could mean they'd moved elsewhere by then, or maybe even gone extinct in that region. We just don't know for sure yet.
A dynamic world, then.
Yeah.
So who else was living there? Who were Atrociraptor's neighbors in the horse thief member times?
Well, the holotype spot itself only yielded Atrociraptor, so we don't know its immediate neighbors at that spot, but we know the general fauna of the horse thief member. It's called the Edmontosaurus regalis pecorinosaurus canadensis zone. So those two herbivores were super common.
The duckbill and the horned dino. Got it.
Yep. Plus other herbivores like the armored ankylosaurs, Edmontonia, and Anodontosaurus. Other hadrosaurs, too, and bits of pachycephalosaurs, the bone-headed guy.
And other predators besides Atrociraptor.
Oh, yeah. There were ostrich mimics like Ornithomimus and Struthiomimus, the small troodonid Albertevenator, some bird-like Canagnophids, a Pataraptor, and Epicurosinotes. And while they haven't been found in the horse thief member itself, things like Dromaeosaurus, Paranicodon, Retardestesia are known from just above or below it, so they were likely around too.
And the big boss.
The big apex predator was definitely Albertosaurus, the Tyrannosaurid.
Right. A tough neighborhood. What about later in that potentially drier Tolman member time where those other teeth were found? Who was around then?
Okay, that's the Hyperchrosaurus altispinus saurolophus osborni zone. So if Atrociraptor was there, it would have shared the landscape with Albertosaurus again, Hyperchrosaurus, probably one or more types of troodontids or nithamidids, maybe other dromaeosaurids too.
Any differences in the fauna?
Interestingly, smaller dinosaurs seem maybe a bit more common, or at least better represented, in the Tolman member fossils. Things like the small horned dino Montanoceratops, the dome-head Spherothilus, the little runner Parksosaurus, even in Alvarez, those weird little guys with the tiny arms and big single claw.
Huh. But they might have been around earlier, too, just harder to find.
Exactly. Fossil preservation bias. Smaller animals are just less likely to fossilize well, especially in certain environments.
Makes sense. And it wasn't all just dinosaurs, right?
Yeah.
What else shared this late Cretaceous Alberta?
Oh, absolutely not. The Horseshoe Canyon Formation gives us a fantastic snapshot. Loads of different fish, ray-finned fish, sharks, amphibians like frogs and salamanders, lizards, and turtles. Turtles were everywhere in those warm wetlands. Snapping turtles, soft shells, odontocetes, even the giant basomies.
Wow.
Plus the semi-aquatic Choricidae Champsosaurus, kind of crocodile-like, but not actually a croc.
And plants. What was the vegetation like?
Very diverse. Lots of conifers, pines, redwoods, cypresses, yews, ginkgo trees too. True cycads seem to be missing, but related things like seed ferns were there. Flowering plants, angiosperms were around globally, but their body fossils are a bit rare here, mostly known from seeds and pollen. Things like plane trees, dogwoods, myrtles, lotuses, laurels, and then tons of non-seed plants known from spores ferns, tree ferns, horsetails, mosses, liverworts, all contributing to that lush, wet environment.
What a rich world. Just incredible complexity. Okay, well, as we start to wrap up this deep dive, let's maybe recap the key takeaways about Atrociraptor.
Sure, so we've seen Atrociraptor was a really distinct dromaeosaurid from late Cretaceous Alberta. Its key features: that deep snout and those fairly uniform backward slanting teeth, Its exact spot on the family tree caused some head scratching, but the consensus now strongly points to it being a Sauronitholestine.
Right.
Those unique skull features suggest it might have been specialized, maybe for tackling larger or tougher prey compared to some relatives, and it lived in this warm, humid, wetland world alongside a huge cast of other dinosaurs and a rich variety of other animals and plants. And, crucially, like we said at the start, this savage robber, totally real, not just a movie monster.
It really just hammers home how incredible and sometimes, frankly, weird life on Earth has been.
Yeah.
And it also, I think, really highlights how science pieces together these stories from often just fragments, this constant process, isn't it? Revising ideas, finding new clues.
It absolutely is. And that actually brings up a final thought, maybe something for you, the listener, to chew on. Given that Atrociraptor made the jump from fossil beds to blockbuster movies, and it's completely real, it makes you wonder, doesn't it? What other creatures from myths, legends, maybe even cryptozoology might actually have roots in real prehistoric life? Creatures whose stories are just waiting out there, buried, waiting for someone to find them and figure them out. Definitely something to ponder.